Okay, welcome to our lesson on probability. Today we're going to be looking at two rules in probability, which is called the AND rule and the other one called the OR rules. Okay, in probability, anytime you come across the word AND, you will always times the probability of those two events. Okay, now the probability of event A and event B both happening is equal to the probability of event A multiplied by the probability of event B. Now, the AND rule only works when events A and B are independent. One event happening does not affect the other happening. Okay, so we are saying that if you want to find the chance of two things happening at the same time, then you're going to basically just times their chances of happening separately. We're talking about independent events. Independent events are events that don't affect each other. The chance of one happening has got nothing to do with the chance of the other one happening. Okay, for example, if I'm throwing a coin, my cone can land on a head or it could even land on a tail. That's what could happen. So it could be landing on a head or on a tail. Okay. Now the chance that it's going to land on a head is going to be basically 1/2. And the chance that it's going to land on a tail is again going to be 1/2 because there are only two options. It's either head or a tail. So the two outcomes would be head or a tail. That's why the bottom number is a 2 here. There is one head out of two sides. So that's 1/2. And there is one tail out of two sides. That's 1/2. Now, again, what I could also do, I could throw a dice. You know, a dice always have 6 sides in it, numbered 1 all the way to 6. And this dice has got a chance of landing on any number 1, 2, 3, 4, 5, or up to 6. Now, the chance of it landing on a 2, for example, is 1 out of 6 because there are 6 options, and 2 is just 1 out of the 6 options that I'm having. The chance of it landing on a 3, again, is going to be 1/6. Now, when I'm throwing a coin and rolling a dice at the same time, the chances of the coin showing a head or the coin landing on a head and the dice landing on a 2 are just independent. They don't affect each other. Okay. So what we can do is to try and find out the chance that the coin will land or will show a head, while at the same time the dice will show a 2 or actually land on a 2. So to do those two things, all you need to do, you times their probabilities. Right? So we are saying that the chance that I'm going to roll a 2, the chance that I'm gonna that the coin is gonna land on a head and the die is gonna land on a 2. Okay, I can write like that, H2, which means H and 2. Okay, so there's gonna be the probability that the coin will land on a head and the die is gonna land on a 2. Now we say that what you need to do is to times the probability separately. That's the rule, because they are independent, they don't affect each other. The chance of the coin showing a 2 is gonna be 1/2, and of the dice showing showing a 2 or a 6 or anything, let's say a 2 here in our case, is basically going to be 1/6. So you do 1/2 times 1/6, which is going to be 1/12. So these two events are independent. They don't affect each other. To find the chance of them happening at the same time, you just times their probabilities separately. Okay. So we are finding today the probability of independent events happening at the same time. Now let's look at this example one before you try a couple of questions. We have a biased dice has a probability of 0.1 of landing on a 6. The dice is rolled twice. What is the probability that the two sixes are rolled? Okay, so you are throwing this dice twice separately. The chance of it landing on a 6 is not 1/6 now because it is biased dice. Okay, so the chance of it landing on a 6 is not 1/6. So they all don't have equal chances. But you see, now you're rolling it twice. You are doing it for the first time. So for the first time, the chance that it's going to roll, that's going to land on a 6 is basically 0.2. That's for the first time. And then for the second time, again, you roll it again. The chance that's going to land on a 6 is again just 0.2. Okay? But they're separately because you're doing them separate. Now, the chance that's going to land on a 6 for the first time is independent. of the fact that it's going to land on a 6 the second time. So these two things don't affect each other. Because of that, if I want to find the chance that it's going to land on a 6 and a 6, all I will need to do is to times the chance that it's going to land on a 6 for the first time and it's going to land on a 6 for the second time. And all I need to do is to times them. That's going to be 0.2 times by 0.2. So 0.2 times by 0.2. And that's going to be 0.04. Okay. So the chance that it's going to land on a 6 and on a 6 is going to be 0.04. Okay. So just times if they're independent. I would like you now to pause the video and try question 1 and question 2. Pause the video and try question 1 and question 2. Okay, I'm just going to do a couple of questions there for you quickly. Doing question A, I'm just going to do maybe go over 3 questions in question 1, maybe that. Now, a fair cone is tossed and a fair 6-sided dice is rolled. Find the probability that the results are a head and a 6. Now, the chance of a coin showing a 6, the chance of a coin landing on a head is basically 1 out of 2. Okay, because there are 2 chances, head or tail. So there are 2 chances, but one of them is a head. The chance that a 6-sided dice is gonna show a 6 is basically 1 over 6 because it's a fair dice. It's 1 out of 6 chances. So we want to find the chance that a head will show on the coin and a 6 on the dice. Now we've used the word and. Every single time you use the word and in probability, you just times them. So head and a 6 is going to be chance that's going to be a head times by chance that's going to be that the dice is going to be a 6. So the answer is basically 1 out of 12. Okay, so that's how to do that. Now picking at E, he says a head and a multiple of 3. What you need to think about here is to think about all the outcomes that you can have on a dice. Okay, all the outcomes that you can have on a dice will be either 1, 2, 3, 4, 5, 6. Now, so if you're talking about the multiples of 3 here, we're going to be picking 3 and a 6. These are the only multiples of 3. So they are 2 out of 6. Okay. So with the coin landing on a head or showing a head, we know it's 1 over 2. And with the dice showing a multiple of 3, yeah, 3 times table, we know it's basically going to be 2. There are 2 of them. So 2 out of 6. You can simplify that to become 1/3. So now, to find the probability that you're going to have the head and the 3 times table outcome is going to be the chance that it's going to be a head timesing by the chance that you're going to end up with a number in 3 times table. So it's going to be 2 over 6. And all you need to do is to times them. So I'm going to be having 2 over 12. And if you simplify, you're going to get 1 out of 6 on that one. Okay. Now doing question 1 as well. A tail and a factor of 5. Obviously, a tail is going to be just 1 over 2 because there's 1 tail out of 2 outcomes. So a tail is going to be, probability of getting a tail is basically going to be 1/2 on the coin. Probability of having a factor of 5. Factor of 5 is any number that you can times to get 5. So 1 fits into 5 and 5 fits into 5. So that's going to be 2 out of 6 again. Okay. Factors of 5 are the numbers that go into 5. They're the numbers you can times to get 5, which in our case is 1 and 5. So there's 2 out of 6. And all you need to do is to times them up. All you need to do is to times them up. Okay. Now we're just going to leave that there, and we're going to come back and try question 2 at some point.